Imagine waking up to a world utterly changed. The air feels thicker, almost as if you're moving through water. Every step is a struggle, as if invisible weights are pulling you down. The ground seems to clutch at your feet, making each movement a Herculean effort. This is Earth if gravity suddenly doubled. Trees would bend under their own weight, and birds would find it nearly impossible to take flight. It's a thought experiment, but one with fascinating implications. How would our daily lives change? How would our bodies adapt? The familiar would become strange. Simple tasks like walking or lifting objects would become monumental challenges. The impossible, a daily reality. Imagine trying to run, jump, or even stand for long periods. Our planet in this scenario wouldn't just feel different. It would fundamentally change. Mountains might crumble and rivers could alter their courses. The very fabric of our existence, from our biology to the environment, would be reshaped by this invisible force made twice as strong. Animals would struggle to survive, and ecosystems would be thrown into chaos. The delicate balance of life, finely tuned over millennia, would be thrown into disarray. Plants might not grow as tall, and some species could face extinction. This isn't just a scientific curiosity, it's a lens through which we can examine the intricate connections between our planet and its inhabitants. Scientists would have to rethink everything from physics to biology. It's a lens through which we can examine the intricate connections between our planet and its inhabitants. The interconnectedness of ecosystems would be more apparent than ever. By exploring this hypothetical scenario, we gain a deeper appreciation for the delicate balance that makes life on Earth possible. It reminds us of the fragility and resilience of our world, urging us to protect it. To understand this doubled gravity world, we need to delve into the basics, mass and gravity. These two fundamental concepts are the building blocks of our universe, governing the motion of planets, stars and galaxies. Gravity is the force by which objects with mass attract each other. It's the reason why apples fall from trees and why we stay grounded on Earth. The more massive an object, the stronger its gravitational pull. This is why massive mountains and boulders exert a noticeable force, even if we don't feel it directly. If Earth's gravity doubled, it means our planet's mass increased dramatically. This isn't just a small change, it's a colossal shift that would alter the very fabric of our daily lives. This increase in mass would amplify its gravitational pull on everything on its surface, including us. Simple tasks like lifting objects or even walking would become significantly more challenging. We'd feel this extra weight constantly impacting our every move. Climbing hills, running, or even standing for long periods would require much more effort and energy, but the changes wouldn't stop there. The increased gravity would affect weather patterns, ocean currents, and even the way plants grow. A more massive Earth would also impact its orbit, its atmosphere, and even the Moon. The Moon's orbit might shift, leading to changes in tides and potentially affecting marine life. The consequences of this sudden shift would ripple through every aspect of our planet's delicate system. From the smallest microorganisms to the largest ecosystems, everything would feel the impact of a doubled gravity Earth. Life on Earth has evolved under the constant, predictable force of gravity. A sudden doubling would be catastrophic. Imagine the struggle birds straining to take flight, their bones no longer strong enough. Animals built for speed and agility would find themselves earthbound, their movements labored and slow. The delicate balance of predator and prey would be thrown into chaos. Survival would depend on adaptation. Humans wouldn't be exempt. Our bodies, too, would bear the brunt of this increased force. Our bones, our muscles, even our internal organs would struggle to function under the doubled weight. We would be forced to adapt, to evolve, or to perish. Here's a counterintuitive thought. Even with gravity doubled, you could still float in water. How is this possible? It comes down to buoyancy, a principle that depends on the weight of the displaced fluid. While both you and the water would weigh more under doubled gravity, the ratio remains the same. The upward force of buoyancy would still counteract the downward pull of gravity, allowing you to stay afloat. This quirk of physics offers a small but fascinating glimpse into how our doubled gravity world would operate. Even amidst the dramatic changes, some fundamental laws would remain constant. Section 5. Nature's upheaval from trees to volcanoes. In this section, we explore the dramatic transformations that our planet would undergo, from the lush greenery of forests to the fiery eruptions of volcanoes. The plant kingdom wouldn't be spared either. The intricate balance that sustains plant life would be thrown into chaos. Imagine towering trees, once symbols of strength, now collapsing under their own weight. These giants of the forest, which have stood for centuries, would be unable to withstand the new gravitational forces. Their root systems, no longer able to support the massive trunks, would fail. The very foundation of these trees would give way, leading to widespread forest devastation. The delicate capillaries that transport water and nutrients from roots to leaves would be overwhelmed. This vital process, essential for plant survival, would be disrupted. Photosynthesis, the process by which plants convert sunlight into energy, would be severely hampered. Without efficient photosynthesis, plants would struggle to produce the energy they need to grow and thrive. And the changes wouldn't stop there. The entire ecosystem would be affected, leading to a cascade of environmental shifts. A more massive Earth would likely experience increased geological activity. The pressure beneath the Earth's crust would build up, causing more frequent and intense geological events. Volcanoes, dormant for centuries, might roar back to life. The increased pressure could trigger eruptions, spewing ash and lava into the atmosphere. Earthquakes could become more frequent and intense. The shifting tectonic plates would lead to more seismic activity, shaking the very ground we stand on. The very air we breathe would feel different. A denser atmosphere would alter the way we experience our environment. A denser atmosphere would press down on us, making each breath a conscious effort. The increased air pressure would affect our respiratory systems, making it harder to breathe. Weather patterns would shift, potentially leading to more extreme storms and unpredictable climates. The balance of our weather systems would be disrupted, resulting in more frequent and severe weather events. Section 6. A silver lining, potential benefits of a higher gravity world. Amidst these dramatic changes, could there be any positives, perhaps? Consider the human body's remarkable ability to adapt. Over generations, our bones and muscles might evolve to be denser and stronger. Weightlifters, long accustomed to pushing their physical limits, might find a strange advantage in this new world. Their bodies, already conditioned to handle increased resistance, might adapt more readily. However, these potential benefits are overshadowed by the sheer scale of the challenges. Adapting to a doubled gravity world would be a monumental task, one that would test the limits of human ingenuity and resilience. Section 7, bringing it to life, visualizing the impossible. It's one thing to describe these changes in words, it's another to truly grasp their impact. Imagine watching a simulation that shows, in vivid detail, how our world would transform. Picture trees bending under their own weight, buildings collapsing, and humans struggling to walk. Visualizations, from animations to virtual reality experiences, can make these abstract concepts feel tangible and real. By engaging our visual senses, we can better comprehend the profound consequences of such a dramatic shift in Earth's gravity. Section 8. Lessons from space astronauts and the pull of home. To understand the challenges of a higher gravity environment, we can look to astronauts returning from space. Having spent time in microgravity, they experience Earth's pull with renewed intensity upon their return. Their muscles, weakened from disuse, struggle to support their weight. Their balance is off. Even simple tasks, like walking, require conscious effort. It's a stark reminder of how finely tuned our bodies are to Earth's gravity. Their experiences provide a glimpse into the challenges we'd face in a doubled gravity world, albeit on a much larger scale. Section 9, a final thought, our responsibility in a hypothetical world. While the scenario of Earth's gravity doubling is hypothetical, it serves as a potent reminder of our planet's delicate balance. It underscores the interconnectedness of all living things and the profound impact even seemingly small changes can have. It also raises ethical questions. If we had the power to alter Earth's gravity, should we? What are the potential consequences, both intended and unintended? These thought experiments, while grounded in science, ultimately lead us to confront our responsibility as stewards of this planet. What are your thoughts on this hypothetical scenario? Share your insights and join the conversation.